So as x gets closer to a from both sides, does the function f of x get closer to some real number L? So you have to be approaching the same y value from both sides. Of course, my pen's going crazy now. All right, you have to approach the same y value from both sides. All right, so as you're looking at a limit, you need to make sure you're approaching the same y value from both sides. Let's take a look at this example down here. We have this function, negative x cubed plus 4x squared, all divided by 2x minus 8. What's the domain? So remember, we were talking about domain earlier. Really, we want to look at what doesn't work, what's not in the domain. What can we not put in for x because it doesn't work in this situation? 4. Why 4? Right, if you put 4 in this denominator, you get 0, and we can't divide by 0. We can put any other number we want in for x into this equation, and we're going to get something out. But if we put 4 in for x, we get 0 in the denominator, can't divide by 0. So our domain would be all real numbers except 4. Or what we'll probably use more often is interval notation, which you probably used last year. So all real numbers except for 4, we would write that as the interval from negative infinity to 4, parentheses, right, because it's not included. We use brackets when it's included. And you may or may not have used this before, little u for union, like putting these together. The interval from 4 to infinity. If you don't use the u, it's not a big deal to me, but a lot of times you'll see it there. All right, so all real numbers except for 4. So we know we can't put 4 in there. We can put anything else in. When looking for domain, a couple things we look for. Can't have a 0 in the denominator, and we can't have a negative under the square root. So those are the two most common things we're looking for with domain questions. All right, so we know can't put 4 in there. Let's take a look at a table. So we can look at limits a few different ways. We're going to look at a table, looking at the graph, and then algebraically. So if we look at a table, we're going to go ahead and type this into our y sub 1. So if you have anything else in there for y, cancel it out. And type in this function, negative x cubed plus 4x squared. Make sure you have parentheses around that. Divided by 2x minus 8. Again, have parentheses around the denominator as well. So rather than, we could fill out this table by plugging in each one of these numbers into the x. That's kind of a pain in the butt. This is another way we can do it. We can actually create a table on our calculator. So to do that, we're going to set up the table first. So we're going to do second, table set is window. So we're going to do second, window. And we're going to set it up, the table start, well, we're going to start it where this one starts, 3.98. And then the change in the table wants to know how much do we go up by each time for the x value. Well, our table is going up by 0.01. So I'm going to put 0.01 for the change in the table. And you want the independent variable and dependent variable to be auto. Calculator is going to automatically figure those out for us. There's some other situations where we'll change the independent to ask, but for right now we'll leave it at auto. And then we want to look at the table. We can go ahead and hit second graph, which will give us our table. And we can see we get 3.98. When we put that in for x, we get negative 7.92. 3.99, negative 7.96. And this should be no surprise. If we put 4 in, there's an error. We can't, right? Because we get the 0 in the denominator. And then negative 8.04, negative 8.08. So let's go ahead and fill that out. Negative 7.92, negative 7.96. This one we'll write undefined. Negative 8.04 and negative 8.08. So going back to what we talked about earlier, finding a limit, what are we approaching from both sides? So from this left side, what's our number seem to be getting closer and closer to? From the right side, what's our number getting closer and closer to? And kind of looking at both of them together, it's kind of easy to see what are we getting closer and closer to. -8, right? Kind of fill in the pattern. If we could put 4 in, it seems like should get -8 out. That kind of fits the pattern here. Well, let's look at the graph. Go back to our calculator and just look at the graph. And this is just in the standard window. You might be surprised what the graph looks like. It's just a parabola. But this equation doesn't look like any parabola equations that we've seen before. Do you think this is just a regular parabola, or is it maybe a little different? How's it different? It is different, right? Because if it was just a parabola, we would have like equation like x squared minus 5x plus 3 or something like that. Well, we can kind of see how it's different over here from our table and what we talked about earlier, the domain, right? We can't put 4 in there. So our calculator is kind of lying to us in a way. It's not showing us that there's a hole right here, right? For this, there's going to be a hole when x is 4, and we've kind of established from here that that hole is happening at a -8. But the calculator doesn't show that. What our graph should look like is something like this. Right? When x is 4, the y value would be -8, but there's a hole there. So it's not a regular parabola. There's a little difference to it. There's a hole. And we can look at this as we get closer and closer from the left side, we get closer and closer to -8. As we get closer and closer from the right side, we get closer to -8. A simple way of kind of doing it, you may feel stupid doing it sometimes, but if you put your fingers at the ends of the graph and get closer and closer to the same x value, your fingers should meet, right? If the limit exists, they should be coming closer and closer together and actually meet. Whether the graph actually meets at that point, like if there's a hole or not, that doesn't matter. But as long as your fingers meet as you're getting closer and closer, that means the limit's going to exist. Now, the last part we're going to look at is the algebraic part. Let's look at this equation. Looks kind of complicated, but with algebra, we can kind of simplify it. Right, so in essence, what we're trying to do here is take the limit as x approaches 4 of this function. So that would be the notation. And what we're going to do that is simplify this algebraically. Right now, we can't put 4 in there because we get 0 in the denominator. Actually, if we put 4 in there, we get 0 on top and the bottom. That's kind of a clue. If you get 0 on top and bottom, that means you need to do something to try and reevaluate this limit. So what we're going to do is factor. We can factor the top and the bottom. So I'm going to leave the limit as x approaches 4 out there. On top, we can take out an x squared, but I'm actually going to take out a -x squared because this leading coefficient is negative, so I'm going to just take that out with the x squared. So if I take a -x squared out, on the inside I'm left with an x, right? If we take -x cubed divided by -x squared, we just have x. 4x squared divided by -x squared, we get a -4. Right, so we get x minus 4 on the inside. What can we take out of the bottom? 2. So if we factor out of 2, we get x minus 4. Well, no coincidence here, but we can factor out x minus 4, which if we put 4 into that, that's what's giving us the 0 on top and bottom. But now if we cancel that, we're looking at a much simpler equation. -x squared over 2. Or we can even think of it as -1/2 x squared. Well, now -1/2 x squared, that is a quadratic equation, right? That looks like a parabola. Negative leading coefficient, so it opens down, just like the one we have here. So, although our graph is not exactly a parabola, it's got that hole, we can kind of see now it looks exactly like this equation, like this graph, only with a hole when x is 4. And now the cool thing is, after we do that simplifying, that algebra, if we put 4 in for x, now if we use direct substitution, we just plug it in. We do -1/2 times 4 squared, we get -1/2 times 16, which is -8. Right, and that's what we kind of came up with from that table earlier. So using those 3 methods, we can see as x gets closer and closer to 4, f of x gets closer and closer to -8. Or we can say the limit as x approaches 4 of our function f of x equals negative 8. So as x gets closer and closer to 4, f of x, or the y value, gets closer and closer to negative 8.